Okay, hello everyone. Today our topic is about magnets and currents. Okay, so let's move into the first part is about magnets. Okay, so what is a magnet? You can find in the first figure like here, like here's a magnetic pole. You can find there's a magnet and here on each terminal there are some metals attracted on it, right? So we can say there each poles of the magnets has the strongest magnetic field, so they can like attract some metals. Okay. So here you can find in our daily life, we have some magnetic poles. Like maybe here we have a rod and here we have a north pole and the south pole, right? We use N to represent for north pole. We use a capital letter S to represent for south pole. Okay, this is for north pole and south pole. Okay, so maybe here we can say, oh, for the Earth is a very big magnetic pole. Like here, we can consider Earth like very magnetic magnets. Okay, so we can consider here it has a rod, and here on the north or on the geography north, that we can say is a south pole, and on the geography south is a north pole. Okay, so maybe why this your magnets can show it is toward north is because here north is attracted by the south pole. Okay, so it's truly just north represented for the like a real geography north. Okay, that means that north is attracted by the magnetic south pole. Okay. So that's a very big difference you can find on the north pole of the Earth that is truly a magnetic south pole. Okay, this is reversed. Okay, so we can find that North Pole is still like attracted by the South Pole, and the same poles have a repulsive force, right? So it's just same to or like similar to our like the electrical poles, right? There's a figure like we are two North Poles, they have a repulsive force, and if we one South Pole and one North Pole, they have an attractive force. Okay, so let's move to the next part, induced magnetism. Okay, so here in this experiment, we are giving iron and steel, and here's a magnet. And if we put iron and steel closer to the magnet, you can find that each iron and steel, they can induce a south pole that is attracted by the north pole, right? And another part will induce north pole, okay? So when you push on the magnet for a little bit time, and when you release it, like iron just lost the magnetism, okay, but still can permanently magnetize. Okay, so we can say that for the iron we can say it's a very temporary like magnetism, but for uh the steel it is a permanent magnet. Okay, so they are quite different. Okay. So here we can say it's a permanent for steel and temporary for the iron. Okay, there's a very big difference between each other. And this is about how to making a magnet. It's the same way as we just discussing about iron and steel. Like you put in a north pole near a like steel or like a magnetized metals. Maybe here we can find the south pole is attracted by the north pole. Okay, and another part, north pole is like in another way of the south pole. Okay, so maybe we can induce north and south magnets. Okay, so here's the exercise. Just try to solve the problem, please. Okay, not very difficult. We just said before. Okay, so for this problem is that which row describes suitable materials for use a temporary magnet and in a permanent magnet, right? So for temporary magnets, we know that, oh, maybe here it just made by the soft iron, right? And for the permanent magnet, it must be steel, right? So maybe we choose B, right? So please remember here that the soft iron is a temporary magnet and steel is a permanent magnet, okay? Okay, so that's it for today's our lesson. So see you next day. Bye.